Hi everyone, I'm Mr. Zhang from Coco Education. So this video will discuss the solutions for some of the round 2 questions from RIPMWC. But please take note, these are the questions recorded by the student, so it's not the actual question. Okay, the phrasing of the question may be different. So we take a look at this one. It says that there's a staircase. It consists of 9 steps. Jason each time can climb 1 or 2 steps. So how many ways are there for Jason to reach the top? Let's say the total number of steps is only 1. Okay, so if the total number of steps is 1, then if this is the case, then the number of ways is 1. Then if the total number of steps is 2, so this one have 2 ways. It's either 1 plus 1 or it can be 2 straight away. Now, when you have 3 steps, this one to find the number of ways, so you check. You can either go from the first one. So from here to here, you just climb 2 steps directly. So this follow the one way here. Alternatively, you can start from this one, 2 steps. So just climb 1 more step. So it carries the number of ways from here. So this 1 plus 2, 3 ways. So for the next case, if number of steps is 4, so either you come from the 2, from 2 to 4, you just climb 2 steps directly. So this is 2 ways. Or you can start from this one, 3 steps. So from 3 to 4, you just climb 1 more step. This is 3 ways. So 2 plus 3, this is 5. So see, follow the Fibonacci sequence. For the next one, we add these two numbers together. 3 plus 5, that's 8. And if the number of steps is 6, there will be 5 plus 8. So 13. If it's 7 steps, this is 8 plus 13, 21. When it's 8 steps, that's 13 plus 21, so 34. And lastly, when it's 9 steps, that's 21 plus 34, so 55. Now, for the question 2 here, we had to make use of this formula. So a squared minus b squared equals to a minus b times a plus b. Now, make use of this here. So this 1 is same as 1 squared. We treat it as 1 squared minus half squared. So equals to 1 minus half times 1 plus half. So for the next group is 1 minus 1/3 times 1 plus 1/3. Then 1 minus 1/4 times 1 plus 1/4. So all the way to the last group, 1 minus 1 over 2023 times 1 plus 1 over 2023. Now simplify the fractions. First one is half, then 3 over 2 times 2/3 times 4 over 3, then times 3 over 4 times 5 over 4. Right, all the way to the last group, this is 2022 over 2023 times 2024 over 2023. Now notice that every two terms, they cancel each other. So look at this one. 3 over 2 times 2/3 equals to 1. So 4 over 3 times 3/4 is equals to 1. Okay, so we group them in pairs. Continue until the second last fraction. So everything in the middle, they cancel each other. This becomes half times 1 times 1 times 1. So all the way to 2024 over 2023. Simplify this. This is 1012 over 2023. So that will be the answer. So for the next question, we have two buckets, A and B. Okay, so at the start, A is 1 liter, B is 0. So the first time A is left is half, B has half. Now for the second time, pour 1/3 of the water from B into A. So B is left with 2/3. This is half times 2/3. So there is 1/3 left. So for A, this is, you just use the total minus 1/3. This is 2/3. Now, when it's the third time, so we pour 1/4 of the water from A to B. Then we are left with 3/4. That's 2 over 3 times 3 over 4. Equals to 2 over 4, so simplify it, is half. So on the other side is also half. For the fourth time, now it will be 1 over 5 from B to A. So we are left with 4 over 5. That's half times 4 over 5. So equals to 2 over 5. Then A is 1 minus 2 over 5, 3 over 5. Now for the next time, the fifth time, so is 1 over 6 is poured from A to B. So we are left with 5 over 6. 3 over 5 times 5 over 6 equals to 3 over 6. That's also half. So the remaining half is in B. So now you should be able to see the pattern. First time, A is half. Third time, A is half. Fifth time, A is half. So whenever the number of pourings is an odd number, the amount left in A and B, they are the same. Each of them is half of the total. So 2023, this is an odd number. We know answer equals to half liters. Now, for question 4 here, we have to use a bit of algebra. So for the one layer, let's say the number equals to A. So basically, it's this fraction here, we let it be A. Then for the two layers, now we know that A is this part. So we replace it with A. This is 1 minus 1 over 8. So simplify this. 1 equals to A over A minus 1 over 8. There's A minus 1 over A. We check for the next case, where it's 3 layers. There's 1 minus 1 over. So now this number in the denominator is the number we get from the 2 layers. This is the A minus 1 over A. So 1 divided by A minus 1 over A, you find the reciprocal. This is A over A minus 1. Now 1 equals to A minus 1 over A minus 1, then minus A over A minus 1. So A minus A cancel each other. This is negative 1 over A minus 1. So rearrange it is also 1 over 1 minus A. Take out the negative sign here. But let's say if it's 4 layers, 4 layers will be 1 minus 1 over. Now the denominator is the number we get from the third step. This 1 minus 1 over A. So simplify this, 1 divided by the number, we get the reciprocal. So it just equals to 1 over A, 1 minus A over 1. So expand the bracket, 1 minus 1 plus A. The answer is A. So notice that we get back to the same number. So every 3 numbers, every 3 layers, it will repeat. Then we will get the same number A. Then second one is A minus 1 over A. Third one is 1 over 1 minus A. Now we have a total of 2023 layers divided by a pattern of 3. So that equals to 6, 7, 4, remainder 1. Remainder 1 means it's the first number of the pattern. So 1 layer is just A. So we work out the value of A. A is 1 minus 1, 1, 1 over 3, 4, 7 equals to 2, 3, 6 over 3, 4, 7. So question 5. So to solve this one, let's make use of the isosceles triangles. Let's start from the smallest one. DE equals to EC. So we can let these 2 angles be 1U. Then we look at the exterior angle of the triangle. This exterior angle equals to the sum of these 2 interior angles. So that's 2U. Now, because AD equals to AE, so triangle ADE is isosceles. This is also 2U. Then let's check for the big triangle ABC. That's an isosceles triangle. So we can let this be 1P, this 1P. And triangle BDC is also isosceles. BD equals to BC. So the 2 base angles are the same. And you see that this triangle ADE is isosceles. The top angle is 1P. The 2 base angles are 2U. So here this will be the same. Top angle is 1P. Then we can deduce that the 2 base angles, they are equal. So they are 2 units each. So let's solve for 1U. Look at this straight angle. That's 5 units equals to 180. So 1U equals to 36. Find the angle ABC. Now ABC, so you can look at this triangle. BCD. This 180 minus 4U. So 180 minus 4 times 36. The answer is 36. So next question. We have 8 identical balls. We have to put them into 4 distinct boxes. So make sure that each box contains at least 1. Now, first way of distributing the balls, it can be 1, 1, 1, 5. Means one of the box gets 5 and the other 3 box gets 1 each. Now this 5 can be any of the 4 boxes. So the number of ways is 4C1, there's 4 ways. Or else it can be 1, 1, 2, 4. So the 4 can be any of the 4 boxes, 4 ways. And the 2 can be any of the remaining 3 boxes, 3 ways. The last 2 left is the one with 1 ball. So that's 4 times 3, 12 ways. Or it can be 1, 1, 3, 3. Now we have 2 of them as 1 ball, so out of the 4 boxes, we select 2 of them to be 1 ball. This is 4C2. Then the remaining 2 will be 3 balls. That's 4C2 is 6 ways. Right, we have to check all the cases where there are 2 groups with 1 ball. So let's check 1, 2. If it's 1, 2, 2, then the last one is 3. For the one with 1 ball, this is 4 ways. Then for the one with 3 balls, it can be any of the remaining 3 boxes. So that's 3 ways. Then the last 2 left, they can only be the 2 balls. So 12 ways also. So the next case is when you have all of them with 2 balls. That's only 1 way. Let's add everything together. 4 plus 12 plus 6 plus 12 plus 1. The total is 35. Okay, for the next question, find the number of 10-digit codes made up with digit 1 and digit 0 such that no 2-digit ones are together. So the most number of digit 0 we can get is 10 zeros. This will only be 1 way. Then let's say we had 9 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, the position where we can place the digit 1 is either on the left or between any 2 zeros or on the right of the last 0. So you check this down arrow, there is 10 of them. We can choose from 10 positions. This is 10, choose 1. We only have 1 digit 1, 10 ways. Then if we have 8 zeros, so 1, 2, 3, 4, 5, 6, 7, 8. Now there will be 9 positions for the digit 1. So out of these 9 positions, we have to select 2 since we have 2 digit 1 now. So this is 9C2, 9 times 8 over 2 times 1, 36 ways. Right, so when it's 7 zeros, I will not draw it again. Now we have 8 positions. We need to select 3 of them. So 8C, 3 is 8 times 7 times 6 over 3 times 2 times 1, 56 ways. Okay, so next one, 6 zeros. Now this is 7 positions. There are 4-digit ones, so 7C4. 7 times 6 times 5 times 4 over 4 times 3 times 2 times 1. 35 ways. Okay. Then let's say if it's 5 zeros, so 6 positions, select 5. 6C5 is same as 6C1, this is 6 ways. Okay. If it's 4 zeros, this is not possible. Now we only have 5 positions, but we have to select 6 positions out of them. That's 6-digit one now. Oh. So this one is a 0 way. Now we just add everything together. So we have 1 plus 10 plus 36 plus 56 plus 35 plus 6. So added together, the sum is 144. That will be the answer.